Number 11, we have this sum of -1 to the n minus 1 over n to the 10th. So again, we're looking for absolute convergence, conditional convergence, or divergence. So the first step is to start with absolute convergence. We're going to look for that first. And so we'll take this series. We'll do the absolute value of -1 to the n minus 1 over n to the 10th. All right, so I got you started. I would like you to pause the video and give this one a try on your own. See if you can determine if it's absolutely convergent, conditionally convergent, or divergent. All right, so let's come back and see if we got to the same conclusion here. Let me zoom back in. All right, so if I clean this up or simplify this after applying these absolute values, what I have is the series of 1 over n to the 10th. So if I think about my flow chart, the first place I start at is, do I have a recognizable form? Do I have a geometric or a p-series? And it turns out that, yeah, I have a p-series here. And my p is equal to 10, which is bigger than 1, which means this is a convergent p-series. And since I'm on the absolute convergence part of this and I got convergence, I'm done. This original series converges absolutely. Awesome. All right, so let's look at number 12. I have the series n equals 1 to infinity. I have -1 to the n minus 1 over the square root of n. So we'll start out the same way with the test for absolute convergence. So we'll put those absolute value bars on there. Okay, and once again, I want you to pause the video and give this one a try on your own. And then we'll come back and see if we get to the same conclusion. Okay, so hopefully you paused the video and gave that a try. Let's see if we get to the same place. Okay, so this looks like it's going to simplify to be the sum of 1 over n to the 1/2. So again, on my flowchart, I start with, is this a geometric or a p-series? So this is a p-series. So I have my p is equal to 1/2, which unfortunately is less than or equal to 1. So this diverges. So you get that this is not absolutely convergent. Okay. The next step is going to be to see if we can get conditional convergence out of this. So we'll make a little roadmap here for conditional convergence. It's -1 to the n minus 1 over the square root of n. Okay, so if I think about my flow chart, I've got alternating terms going on here. So I'm going to need to use the alternating series test. I know the divergence test is limit is 0. That's not going to help. I can't use the positive terms choices. So alternating series test is what I'm going to use here. So I'll start by pulling off the part that has the blinkers. So that gives me a b sub n of 1 over the square root of n, which is greater than 0. So I meet my first criteria for alternating series test. The next thing is to take the limit as n goes to infinity, 1 over root n. So that's 0. So that's good. I meet my second criteria. And then I need to show the decreasing. So I'll plug in n equals 1 into this. Gives me a 1. If I plug n equals 2 in, I get 1 over root 2. If I plug n equals 3 in, I get 1 over root 3. And sure enough, those are decreasing. So that's great. Oh, decreasing. Let me put a check mark there, not a question mark. Yes, I confirmed it's decreasing. So my conclusion is, since I meet these 3 criteria, therefore, you can do the 3 dots if you prefer that rather than writing therefore. The sum n equals 1 to infinity of -1 to the n minus 1 over root n converges by AST. So you want to include all those details in a complete write-up. Okay, so I failed. Now we have to go back and answer the original question, which is it absolute convergence, conditional convergence, or divergence? So we had not absolute. This process here, we were testing for the conditional convergence. And since we got convergence under this, the original series is going to come back as conditionally convergent. Okay. So this is why I put a little roadmap over here as to what thing I'm testing. So when I get to my conclusion, it's really clear to me and I don't have to figure out kind of where I was at and what I was doing. All right, so that is your absolute and conditional convergence. And when we come back, we'll look at the ratio and root test, which are some other tests to help with things like factorials and other issues that might come up, but we can also use those for absolute and conditional convergence as well.